What we want to do here is talk a few minutes about Objective 4.6, Configure, Verify, Troubleshoot IPv4 Standard Numbered and Named Access Lists for Routed Interfaces. Access control lists. What we're going to do is talk about the purpose of them, the anatomy, what's in it, and then we'll write a list. And I'll also do, as a separate video, a demonstration on how to write and apply an access control list. It's going to be a two-step process. First, we'll write it, and then we'll apply it. So with that, access control lists are used to control access to all or part of the network. What that means is we can deny or permit, and the two go together. If we deny something, if we deny one group of computers, we'll permit the other ones. And in this one, it's used to control, for instance, restrict students from the faculty network. So if we had a router here and let's say 3 or 4 networks, and we have a faculty here, a students here, and let's say a finance here, and an admin here, we can control who gets access to what network. And then over here we would have probably our resource network. What we would do is allow the students to get to the resources, but we wouldn't allow them to get to let's say the faculty network, and we probably wouldn't allow the faculty and the students to get to the finance network. Maybe not even admin. We may isolate it so we can restrict access to different networks with the access control list. Identify the different types of traffic by reading the header information, IP, ICMP, TCP, and UDP. What we're doing in ICD-N1 is a standard access control list which can only use the source IP. Get into ICND2 with the more advanced access control lists. We can use other things like the TCP ports and things like that. It's used for traffic filtering and quality of service. When we do quality of service, and again an ICND2 topic, the first thing we're going to do is write an access control list to determine which traffic we're going to apply the quality of service to. It's a two-step process. First, we write the access control list, deny, permit, and I'm going to say all this again on slides, but at the end of each access control list is what's called an implicit deny. Implicit deny, which means that as we go down here, anything that's not been permitted at this point is going to be denied. So we have to have at least one permit statement in an access control list. Once we write the list, then we're going to apply the list to an interface. The interface on the router, and we're either going to apply it as an inbound or as an outbound. So we're either going to control what goes in or what goes out. And you say, why do we do that? Because if we have this whole bunch of people here and the students, and we denied something going in, we may wind up denying access to some other networks that are necessary, depending on how precise we are at writing our access control list. The advantage to denying it on the inbound interface is no routing takes place before, because if we deny it on the outbound interface, it's going to go through the router. It's going to use its CPU cycles in order to do the routing. The rule for applying the standard list is closest to the destination. So SD, standard, closest to the destination, because we can't be quite as precise with it as we will be able to when we get to the extended lists. So access control lists at the router interface, we have the packet coming in here at the router interface. Does it match statement 1? No. Goes to statement 2? No. Goes to statement match statement 1, statement 2, statement 3. If we get down here and it's no, the packet's dropped. This is our implicit deny. implicit deny. If it matches something, is it a permit statement? If it's yes, then we will go to the forward to whatever the destination is. Match a statement, yes, is a permit. If it's a no, we're going to go down here and we're going to drop that packet. So we can permit or deny. List is written using the access list command. The statements are added sequentially and added at the bottom of the list. So if I do a deny 1, permit 1, permit 2, deny 3, and then I want to do something, I want to go up here and do a permit here. If I type the permit 4 statement, it's going to be added to the bottom of the list. Notepad to copy and paste these things. This is for a numbered list. We got numbered list and named list. If we do a named list, and we'll talk about what they look like, and all it's the same process, but give it a name instead of giving it a number. The number that we give it will automatically tell it whether it's a standard list or not. So if we do a named list, then we're going to number the command. So we could, if we had 10, 20, and 10, 20, 30, 40 increments of 10 is the standard on this. If we then wanted to insert something in here, we could put 15, for instance, and here we could put 25. So we can, with the named list, put add commands inside of the access control list. It's read from the top to the bottom, like over here. So the order is significant, the order that the statements go into. If we have something that is too general at the top, either a permit or a deny, then we may preempt what happens at a list at something below. So the more specific commands need to be at the top of the list. Let's see, must have at least one permit statement because of the implicit deny. Order is significant. Implicit deny at the end of the list. We use wildcard bits. Increment or the 255, 255, 255 subnet mask defines a range of addresses. What the increment -1 or 255, 255, 255 minus a subnet mask is going to give us the wildcard bits. A wildcard bit is written like 0.0.0.255. What that tells us, if we're looking at denying or permitting an entire network, 192.168.1.0 network, says the zeros say check to see if it's 192. A 0 says check to see if it's 168. Check to see if it's 1. When we get 1s in the 255, I don't care anything that is under the 1, there has the 1 in the wildcard bit is ignored. It's not even checked. So we could write something like permit 192.168.1.0, 0.0.0.255 will permit the entire 192.168 network. So we define a range of addresses. If we want to permit or deny an individual host, we can either use the 0.0.0.0 as a wildcard mask or use the host modifier. We just say permit host 192.168.1.3, or we can permit 192.168.1.3 0.0.0.0. Just seems simpler to write the word host instead of the entire wildcard mask. So the types of list, I've talked about, alluded to them before. We have the standard numbered and the standard named. Standard number, source IP address only. So in source IP address only, and this is for ICND1 as a standard number. ICND1. ICND2 is going to be extended number and extended name. We can use a source and destination IP address as well as the ports, and we can do ICND in it also. So a numbered standard list, the way we would write access list 2, and if we go from 1 to 99, those numbers are standard. Access list 2 permit 10.253.1 10.2.1.8. And we really should put a host modifier in here. Access list 2 deny 10.253.1.6. The named would be IP access list standard. We tell it's a standard list. My network, permit, whatever, deny, whatever. The difference you'll see here is every time we write a different statement for the access list, we have to write access list and then the number in the standard numbered. In the named, we invoke the access list, standard my network, and this should actually be on a new line. Permit 10.253.1.8 and then deny. We can add them sequentially until we get to the end, and it adds the sequence numbers, the 10, 20, 30 as we do those. So numbered and named. Yeah, numbered and named. Numbered and named. Couple of differences. The impact is the same because they're going to do the same thing, permit or deny a source IP address. So access control list, kind of a flow here. More specific rules at the top, because if I had permitted 192.168.1.0 network, if we had permitted that entire network, and then I go down here and deny host 192.168.1.37, it'll never get here because the 192.168.1.37 goes to this first statement and says, oh, okay, I'm permitted, and it doesn't look any further down the list. So the more specific rules at the top, it's applied from the top of the list down, so that once it finds something that applies, it does that action and doesn't look any further. We got to have at least one permit statement because of the implicit deny. Implicit deny is there, so yeah, at least one for the implicit deny. Once written, it's got to be applied in or out of the interface. If we write the access control list, nothing's going to happen until we apply it. And we can have one access control list per protocol, per interface, per direction. And remember, we apply them in or out of the interface. So a couple of depths about what goes on. Got one slide ahead, but anyhow, let's look at kind of an illustration of what these things are. We have, if we're going to permit 10.1.1.1, the more specific is host A is 10.1.1.1, it's permitted. Over here, 10.1.1.2, if the source is 10.1.1.x, we're going to deny it. So it looks at this one, doesn't apply. It goes to the next statement and says, oh yeah, I'm a 10.1.1 dot something, so I am denied. Over here we have the 10.1.1, the 10.1.1x, and then 10xxx is permitted. So 10, if it starts with 10, is 10.3.3.3. After it's gone through, no, okay, I'm a 10, so I can get there. So hopefully you can see that here, that the order is important. The explicit, the more specific at the top, and then the more specific, the entire 10.1.1 network, and then the least specific, the 10 network after that. So top to bottom, more specific to less specific. To implement it, the generic syntax is access list, and then the access list number, deny or permit, and then the source IP address, and then the wildcard mask. So what we would type is access ACCESS list to permit 68.2.0.0.0.255. That would be okay. Then everything else would be denied if that was the only thing we wanted to permit, because the implicit deny would then take place. So the generic syntax, access list, the number, deny or permit, the source IP, and then the source wildcard. And the numbers are 1 to 99 for the standard list. And then the next command in a numbered list would be access list 2, and then whatever we wanted to do with it. Plan the location, the router and the interface, the direction in or out on the interface. A standard list should be placed near the destination of the packet so that they do not unintentionally discard packets that should not be discarded. It's much larger than the extended that we'll get to in ICND2. So we're going to have the standard list. It's going to be applied closest to the destination. Can only match the packet source IP. Identify the source IP address as they go in the direction that the ACL is examining. Configure one or more access list global configuration commands to create an access list, keeping in mind the list is searched sequentially using the first match logic, top to bottom. When it finds one that applies, it applies. It doesn't look any farther. So if we go down 1, no, and we had a 2, 3, 4, and 2 is yes, it says, okay, this one applies. I'm not going to look any farther. I don't want to know if there's anything else down there. Default action, if it does not match any commands, is to deny or discard the packet. That's the implicit deny. Implicit deny in it. Enable on the chosen router interface in the correct direction in or out. And sometimes that's a pretty subjective, which way do we want to enable the access control list. And back to the standard SD, standard closest to the destination, is they should be applied in or out on the interface. So we talked about access lists. They're designed to restrict access to the resources. We had two types, standard and extended. The objective for ICND1 only covers the standard list, which the standard is the source IP address only, is the only thing that we can control. Processing starts at the top of the list, goes down the list until it finds something that applies. Once something applies, it does that, doesn't look any further. If it's a permit, then it goes. If it's a deny, it says, okay, I'm done. Proceeds down until a match is found. If no match is found, the packet is dropped because of the implicit deny at all of the lists. And because of that implicit deny, we need to have at least one permit statement. I remember a time when we were trying to deny access to an individual. We went in and did this really cool access control list, deny that specific IP address. Forgot to use the permit any, everybody else, in the ACL statements. And lo and behold, entire internet went down, because what we're trying to do is deny that individual access to the internet. Go back, change the access control list that would then permit everybody else to have access to the internet, and everything worked fine. So you do have to have at least one permit statement in an access list. So we'll do a demo in the next video. See you there.